Hello everyone, and thank you for joining me for another math lesson with Mr. Walker. Today, we are back again talking about volume, which is awesome, one of my favorite subjects. And we're actually going to be solving some word problems today involving the volume of a rectangular prisms, and using some different lengths and widths and heights and different things like that to help us do some problem solving and really kind of synthesizing our volume knowledge so far, like putting it all together and using it to do some real world problem solving things. We're going to have to kind of play around with some numbers and do some outside the box kind of thinking, which is awesome. Outside the box, rectangular prisms. Oh, it's funny, it all goes together. Anyway, you don't need much today. Something to write on, something to write with. I am going to be going over some problems from the problem set that's attached in the module, so if you want to grab that and download it, you can. But if not, you can follow along with me because we're basically just answering some word problems that revolve around volume. So once you have those things and you're ready to rock and roll, go ahead and click continue and we'll keep going. Alright guys, so you'll see a common theme in these problems today, which is we're going to be helping my man Jeffrey here with some planters. So he's going to be doing a lot of different things with planters, and we're going to have to kind of problem solve along with what he's trying to do, what he's trying to accomplish, okay? So our first problem that he has is it says that Jeffrey's first planter is 8 feet long and 2 feet wide. The container is filled with soil to a height of 3 feet in the planter. What is the volume of the soil in the planter? Okay, so it seems like he's got a planter here. I shouldn't say it seems like it. He has a planter. And that planter is 8 feet long and 2 feet wide. So we have a length and a width so far. Okay, so that's easy enough. So if I were to just start to sketch this out, because you know me, I like to draw some pictures, kind of visualize it, right? So I'm going to try to sketch a rectangular prism here. Don't laugh at my drawings. All right, and that's one thing I have to get across. Like, none of this stuff ever has to look perfect, guys. As long as you guys can tell what you're drawing and what you're working with, and you can explain it back to somebody, that's all we're looking for, okay? So I'll get my planter going here, my saggy kind of planter. Maybe it's been sitting out in the sun in the rain too long. But you can kind of get the idea here. So here's my planter, okay, and it's 8 feet long, he says. So we're going to put 8 feet here, and that's going to be my length down here, which is good. And it's about 2 feet wide. It says 2 feet wide. So my 2 feet, that's going to be, this little portion right here. And let's keep going here. The container is filled with soil to a height of 3 feet. Okay, so he fills it up about 3 feet here. So say 3 feet from the bottom all the way up to, I don't know, let's say it's right about there. And I'm actually going to go in, since I have access to some different colors here, I'm going to draw my soil line right about here, right? So that's where he's filled it up with soil to about this height, to that 3 feet, okay? So what is the volume of soil in the planter? And we're going to explain our work using a diagram. Well, we know, because of some of the work we've done, we know that volume is equal to the length times the width times the height of whatever figure, whatever rectangular prism we're trying to find the volume of. So if I were to take my length of 8 feet, my width of 2 feet, my height of 3 feet, and multiply those together, I would get my volume. So 8 times 2 would be 16, times 3 would be 36, 48. So 8 times 2 is 16, times 3 is 48. So there are 48 cubic feet, or feet cubed, right? We're not talking about centimeters or meters, we're talking feet. So 48 cubic feet of soil in the planter. So I read through my problem, found my important information, I drew out something, I sketched it out here with my soil and everything like that, and then I did my work and I explained it, okay? I wrote out an answer, 48 cubic feet of soil in the planter. So I have all my work done here. I was able to show it using a diagram, just like the problem asked. So I think we're pretty good to go on this one. So let's take a look at the next problem and see what else we can help Jeffrey out with here. So now it says that Jeffrey wants to grow some tomatoes in 4 large planters. He wants each planter to have a volume of 320 cubic feet, but he wants them all to be different. So 4 different ways Jeffrey can make these planters and draw diagrams with the planters' measurements on them. Holy cow, a lot of stuff going on here, but let's just take a look one more time. He wants to make 4 large planters, and he wants each planter to have a volume of 320 cubic feet. So that means no matter what kind of a rectangular prism we draw, it's going to need to have a volume equal to 320 feet cubed, or cubic feet. Alright, so that's easy enough. We want to show 4 different ways that he can make these planters. So a couple steps involved here, but nothing too terrible, nothing that I don't think we can figure out, because again, we know what volume is, we know how to find the volume of something, so we should be able to do this. Alright, so right after that, I already kind of sketched something out, knowing that our rectangular prism has to have those 3 sides that, when I multiply them, is going to end up to 320. So we know that the volume is going to be 320, and that's going to be equal to the length times the width times the height. So let's think about the number 320 for a second. When I see that, I could kind of think of it as like 32 tens, right? If I had 32 times 10, 32 times 10 would get me 320. So I could start to kind of think of it, okay, so I have like 2 numbers here, so I need 3. So what if we did something like this? What if I had one big long rectangle here, and I can make that into a rectangular prism. Alright, and let's say that this length here is 32. So I have 32, alright, and then this 10, I just want to break this 10 into 2 numbers. So let's think of it this way. What 2 numbers can I multiply together to get 10? Well, I can do 2 and 5, right? So let's say that this is 32. We'll say that this guy here would be 2, going up and down like our height. Our width we can make as 5. So now if I take 32 times 2 times 5, well, 2 times 5 is going to give me 10. 32 times 10, we know that's going to be 320. So 320 cubic feet. So this shape here, this would work, okay? So I would have 2 as the height, 5 as the width, 32 as the length here. Okay, so that's cool, so that would work. Let me go ahead and grab a picture of this guy, move it over here so we don't lose it, so we still have it up here. So that's kind of like a long, flat planter. It's only 2 feet high. But let's go back, and what we kind of already started here, let's take this a little bit further. So let's think about now these 2 numbers again, this 32 and this 10. Instead of breaking apart the 10 this time, I'm going to keep 10 as a measurement. So let's say that we had 10 feet as a length. Alright, let's break apart this time, let's break apart the 32. And I know that 4 times 8 would be 32. Alright, so let's do that. I'm going to do it, let's see, I can make 4 my length, or my height, or my width. Off here, yeah, close enough. Okay, so I'm going to say that this guy is going to be 4 feet high. Alright, and we'll say that it's 8 feet in length. Well, in width, I guess. So if we did 4 times 8 times 10, that should give us 320. That would be my length times width times height. So 4 times 8, as we know, would be 32, times 10 would be 320 feet cubed. So that's another route we could go, another shape that we could make that would get him that 320 feet cubic feet. Let's go ahead and put this guy up next to the other guy. So we got 2 different shapes. He wants 4 different ones. Okay, so why don't you guys take a second, see if there's any other combinations you can come up with, and then we'll see what other shapes we can make. Well, we kind of already used up our 32. We had broken that into 2 numbers. We used up our 10. We had broken that into 2 numbers. So let's see if there's any other combinations that we can think of. Well, I could think of 32 as 16 times 2. That would give me 32, right? So I could do a rectangular prism that's 16 length, 2 feet high, and 10 feet wide, or vice versa, just using any of those combinations, the 16, the 2, and the 10. I could also think of it as, well, let's see, what other combinations can I use to make 10? Well, I could use a 1 and a 10, right? So I could do 32 times 1 times 10, and that could give me another one. So basically I would have just like a long, really super long, super skinny kind of guy here. It'd be a little bit wider than our one was up here because that was 5, so this one would be 10, 32, but only 1 centimeter high, only 1 centimeter high. So that would be another combination, another shape that I could make. Okay, so you could just kind of start thinking about the different combinations you can make. So I'll let you guys come up with a couple more. And again, you don't have to use the 32 and the 10 like I did. So I split up my 32 times 10. I split up my 320 into a 32 and a 10. Okay, but if you want to split it up other ways, you can. For example, 8 times 8. 8 times 8 would give me 64. So then I could just figure out, well, 64 times what might give me 320? Well, it would actually turn out to be 5. So I could do a shape that's 8 times 8 times 5. Okay, you could just kind of start plugging around with some numbers and seeing what fits and what 3 numbers you can multiply by to get to 320. So I gave you a few examples here, so you guys can come up with the 4th one, see what you get, and then let me know, and we'll keep moving on. So just to add on to this, you might be thinking, well, Mr. Walker, why would we ever need to know how to make these different planters in different sizes and things like that? This Jeffrey guy's kind of crazy. And, you know, he might be a little bit, and that's okay. Because the reason this might come in handy is, let's say you're trying to plant something like tomatoes, and you know that they need 320 cubic feet of soil, because a lot of times when you're planting different things, it's going to tell you, okay, you want to have this much space for it to grow up into. So this one, for example, has 320 cubic feet. So you want to make a planter that's big enough to hold your plants. But let's say your backyard doesn't allow you to have something that's this long and flat in your yard. So you have to build something a little bit deeper, a little bit taller, right? That's where something like this, that 8 times 8 times 5, that might come in handier for you to build, because that one's going to be taller and not quite as wide as some of the other shapes we have seen here. Okay, so this is actually something that you could use in the real world, and that is used in the real world quite often. So it's important to be able to think of this and to understand that volume can be the same volume, even if the shapes look different from each other. They could still take up that same amount of space in 3D. Okay, all right, let's keep helping out Jeffrey here. This one, it says that he wants to make one planter that extends from the ground to just below his back window. The window starts 3 feet off the ground, and if he wants the planter to hold 36 cubic feet of soil, name one way he can build the planter so that it's not taller than 3 feet. We want to explain how we know that. Okay, so read through the problem. Again, it says that his window starts 3 feet off the ground, and he wants to make a planter that goes just below his back window, just below that. Okay, and he wants it to hold 36 cubic feet of soil. All right, perfect. So he doesn't want it to be taller than 3 feet. So basically, if we're thinking of this is going to be his window, okay, with his nice curtains in the window here. Beautiful. I know, I'm an artist, right? So he wants to build a planter down here that doesn't come above that window. And we know the space that he has from the ground to the window is about 3 feet. Okay? So basically, we're already being told what one of our sides is. Because again, we know that the volume equals length times width times height. And so far, we know that our volume, we don't know what the length is, we don't know what the width is, but we know the height is going to be 3 feet. That's as high as we can go. So if we have a planter here, let's just start kind of sketching this out a little bit. We have this planter, we know that this side is going to be 3 feet. And we know that the total volume inside of this planter needs to be 36 cubic feet. 36 cubic feet. So let's think about this for a second. Do we know, is there anything that we can multiply by 3 to get 36? So is there a number, just call it x for now, that we can multiply by 3 and get 36? Sure, 12, right? 12 times 3 would give us 36. So that means that the area of this base down here, like the area of the top of this right here, the area needs to be 12. And we know that because when we were taking a look at volume before, and let's say like these 3 feet, if we split this rectangular prism into its 3 feet, whatever this area is, we're going to have to do that 3 times. So 12 is going to have to be the area. So what are two numbers we can multiply together to get 12? Right, there's a couple different things. So if I were to kind of like zoom in on this base here, okay, and just represent it in 2 dimensions, we know that we could do 4 times 3, that would give us 12, because that's what we need. We need 12. We could also do 6 times 2. We could also do 12 times 1. Any of those would work as the base. For me, I'm going to do the 3 times 4. I don't know why. It just seems like a good measurement to have there. So I'm going to say that the height of this is going to be 3. The width of it I'm also going to put as 3. So right here, that's going to be 3. And then this is going to be 4. 4 feet. So if I did 3 times 4 times 3, so length times width times height, that would give me 36 feet cubed. So here is what his planter would look like. It would be 3 feet wide, 4 feet in length, and 3 feet high. Okay? And again, there's a few different possibilities here. So you could come up with something a little bit different as long as your volume is 36 cubic feet and it doesn't exceed 3 feet in height. Alright, let's see if we can help Jeffrey with one less problem here. And it says that after all his gardening work, all the hard work he's been doing, he decides that he needs a new shed. Because why not, right? He needs a new shed. His current shed is a rectangular prism that measures 6 feet long, 5 feet wide, and 8 feet high. And he realizes he needs a shed with 480 cubic feet of storage. So let's do this. First, I'm just going to draw out his shed. So he says it's 6 feet long, it's 5 feet wide, and 8 feet high. So let's start with that. Yeah. Alright, so here is Jeffrey's shed that he has now. 6 feet by 5 feet by 8 feet. Okay, that's easy enough. So there's a shed that he has now. He needs a new one that needs to be at least 480 cubic feet. Okay? So he wants to know if he doubles both of these. What if he doubles this? That's what he's thinking first. Alright, let me just take what I have. Let me just double it. And let's see if I'm going to get something that's going to be more than I need. So right now, the current volume of his shed is, let's see, the volume of this guy is going to be 6 times 5 times 8, which would be, well, 6 times 5 is 30. 30 times 8 would be, so the volume of this would be 240 cubic feet. Okay, so feet cubed. So that's how big this shed is now that he currently has. He wants to know if he doubles all of these lengths and widths and everything, if that would give him the 480 feet that he wants. Because 240 times 2 is 480, right? So it makes sense that that would seem right, but let's just double check. He wants to double all of these and see what he gets. So now that means that this 6 doubled would be 12. 5 doubled would be 10. And 8 doubled would be 16. Sorry for my overlapping sheds, but hopefully this makes sense. So now I could still find the volume of this. So we'll say that the volume is equal to 12 times 10 times 16. And if we did that, we would get 1,920 feet squared. So that's a big, right? So by doubling each dimension of the shed, we're actually going to get a shed that's 8 times the current size, because 2 times 2 times 2 equals 8, right? We doubled each one of these. 2 times 2 times 2. So now it's going to be 8 times as big. All right? So to double the volume, he really only needs to double one dimension. If we were to change this 6 to a 12, or this 5 to a 10, or this 8 to a 16, that would give us double the amount of volume. Okay? He doesn't need to change all of those. He just needs to change one of those sides. Alright, there's some more questions about Jeffrey and his shed on the problem set. I'm going to let you guys take a look at those. I think you've heard me talk through these problems enough. You're feeling pretty good. If you have any questions, comments, or concerns, though, please reach out. Please let me know. I appreciate all the hard work you guys have been doing, all the awesomeness you've been showing me with volume, and I look forward to seeing what you continue to do in the future. Alright, guys, thanks for working so hard, and we'll talk to you soon.